Hello everyone. Till now we have discussed some numerical problems on continuous beam. Today in this class, let us solve some numericals on portal frame. So let us open the Staad Pro software. So let us solve this portal frame. A, B, B, C, C, D is the portal frame. So on BC member, 20 kilonewton is acting, and on AB member, 6 kilonewton is acting. On CD member, 6 kilonewton is acting. So you should remember the sign convention always. The forces going right side is positive. The forces going left side is negative. The forces going upward is positive. The forces going downward is negative. So these sign conventions you have studied in elements of civil engineering. So here this force is acting downward, it is negative, and this force is going right side positive, and this force is going left side negative. So let us solve this problem. So this member is 4 meter, this member is 2 meter, this member is 4 meter. So here totally 4 nodes are there, A, B, C, D, the 4 nodes. So let us start the new project. Give the click on plane, give the name as portal frame number 1. So click on next. Already it is existing, so click on override. If it is existing, click on override. If it is new, it will automatically come to add beam. Let's click on finish. So the window is in 3D view. Click on front view. So the column is it is also a beam, but it is a vertical beam, and this is a horizontal beam. So let us create the member starting from here. So vertical it is 4, horizontal it is 2. Okay, vertical it is 4. So click on 0 here. Take the line vertical and click on 4th node. This is the node is 4 meter. Next beam is 2 meter length, horizontal 2 meter. Again the beam is 4 meter. So click on close. So you can view the dimension. Click on dimension, display for the view. So you can see the three lines with 4 nodes has been created. 4, 2, and 4. So I'll remove this one. So next step is you have to assign the property for these beams, horizontal beam and vertical beam. So click on general. So see here he has given the moment of inertia for all the beams. For this one IAB it is 1. For PC is moment of inertia is 2. For CD is it is 1. So instead of giving the dimension, he has given the moment of inertia. Click on define. So click on general. So I will assume 0.00001 for these two beams. As it is 1, I will assume 0.0001. Click on add. Next is for this one, it is BC beam is 2. So if you multiply for this one 2, so it will change it to 2. So click on add. So now this is moment of inertia 1, and this is moment of inertia 2 of some value 1 into 10 raised to minus 5 meter raised for this one. So use cursor to assign, click on assign on these two. So this is the moment of inertia of 1 into 10 raised to minus 5 meter raised to 4. So click on this one, assign for this one. This is the reference number 2. Next click on close. So to view whether the dimension has been assigned, it will not show because you are not assigned the dimension. You have assigned the moment of inertia. For that case, it won't show the dimension. So next, click on general. So next is you have to assign the fixed support here and here, here and here. At this node, it will automatically take fixed support. You can see any column and beam joint. It is a fixed support only. So here and here I have to assign the support that is fixed. Click on support, create, fixed, click on add, select this one, use cursor to assign, and click on at A node and D node, close. Now next step is you have to assign the loads. This is +6, this is -6, and this is -20. So this +6, it is at a distance. So you have started the node, you have you have drawn this portal frame from this point. Like this, you have proceeded. So this is the starting point for this beam. For AB, A is the starting point. So the D1 for this one is, it is this one. And this is acting over whole length BC, no problem. And for this beam, so starting point is C. So this is the D1. So let us assign the dimensions. So click on loads and definitions, load case details, add, give the name load case 1, click on add, close. Let's select load case 1, click on add. So all are member load only. So this is the member, the load is acting on this member. This is also member, the load is acting on member. This is also member CD acting on the member. There is no nodal load. So it is asking automatic save, click on save. Next uniform force is, that is UDL, that is -20 acting downward. It is acting along global y-axis. Click on add. So you know the reference axis. So this is your axis. This is positive x, global y, global x, and this is global y-axis, and the z-axis is towards you. This is x, this is y. Okay, and this is acting downward, it is -20. So this is going right side, it is plus, this is going left side, it is minus. So for these two loads, you have to choose global x. So already one is assigned now. So again, click on this one. Again, you click on add. So next again, member load, that is concentrated force, that is P. So it is +6, and the D1 is 3 meter for this one. It is the starting point. D1 is at a distance, it is acting at a distance 3 meter from this node A. So it is along global X. Click on add. Next is another load is -6. So the D1. So for this being, the starting point is C. So this is the D1. It is at a distance 1 meter. 1. 0 global X. Click on add. Close. Next to assign the loads for the respective beam. Use cursor. Click on this one. Next this 6 plus 6 concentrated load global X 6 kilonewton 3 meter. So you assign on this one. Next select this one and assign for this one -6. So it is showing left side at a distance from here it is 1, and this is from here to it is 3 meter. Click on close. Next to view the loads again, click on loads. So the scale is very low. So it does reduce the scale. Click on right click on this window, labels. To view the load values, click on load value. Next is scales. So UDL also you are unable to see, and the concentrate load, that is 0.4. So I'll increase by 20 this one, and the pressure, so this one. the UDL kilometer per meter. I will increase by some 50. Apply. Okay. So now you can see the reduced scale. This is -20. This is -6. This is +6. So the next step is analysis and print. Click no print. Click on add. Close. Next is analyze. Run analysis. Save. So zero error is there. Click on go to process mode. Done. Select load case 1. Okay. So here the deflection button is on, but you are unable to see the deflection. So to automatically scale the window, you click on the result setup, result view options, enable automatic scaling. For shear bending, click on OK. So if you next press deflection, you can see the scale has been automatically done. Next, similarly, bending moment. This is the bending moment, red one. This is shear force, W1. So I will first click all the results. Click on results, view value, beam results. Click on bending point, shear at ends, shear at midpoint. Next, displacement. I will tick all these things and not close. Next, to view the only the bending moment, I will untick this shear force and bending moment. Only this button is on. So this is the bending moment diagram. So to reduce the scale, you press Control, scroll the button down. So this is the bending moment diagram. So let us see whether the answers are correct. So now see here, bending moment is here. It is 4.44. There is negative bending moment. There is walking here. The beam has been went up. Similarly, here also it is 4.44, and here also it is 4 point negative bending moment. So this is at the midpoint of the beam. This is 0.476. This is at this one, at this point load. The bending moment is 1.02. You can't see this value. So at the support it is 0.6 is there here. Here 0.577 is there. Is approximate value. And here this one is missing. It is 5.528. That is sagging, positive bending moment. So the results are correct. So next is, let us see the shear force diagram. So this is the shear force diagram. Next is deflection. So first I will take the modeling picture. Click on modeling. So loads. I want the dimensions. First I will take the picture of this one. Click on edit. Take picture. It will ask the ID, or else you can see the ID number. So you can see the picture number 1 only. Next, you click on the results. For that results, you click on post processing mode. Maximize this window. The reflection is on now. First, I will take the picture of the bending moment. First, I will click on these results, view value. Will tick all of these things. Bending on shear, maximum resultant. And not close. First, I will take the picture of the bending moment. We edit, take picture. Picture number 2. Okay. This one over. Next, take the shear force. Click on this one. Edit, take picture. Picture number 3. Next is deflection. Click here. Edit, take picture number 4. Okay. So let us see a reaction here. It is vertical reaction of 20, and here 20. The horizontal reaction here it is 0.54. Here it is 0.54. Let us see this one also. Reactions. See here, the vertical reaction Y it is 20. For this one also, vertical reaction Y is 20, and this one is minus 0.526 kilonewton, minus 0.454 is there, and for this one is final plus 0.54 is there. Here it is 0.526 is there. That is exactly correct. So even if you want to take the picture of this one, click on edit, take picture like this. If you want to do, take picture number 5. Picture number 5 you can give as reactions. Okay. So here also you can see the results value. Reaction is 20 Fy for the node 4 for this node, and horizontal Fx is 0.526. Similarly for the node 1, this one, shear force, sorry, the reaction horizontal reaction is minus 5.26, vertical reaction is 20. So after doing all these things, next you can export the result. First you have to set up the report, which are the results you want. Click on report setup, pictures. You want this, this. Select all these things and on the right side. If you don't want this one, you remove this one. Okay. Next is click on file, export report to the MS Word file. So it will say, it will take the name or whatever the file name is, a portal frame 1, but it will say in the document file. Save. Cancel this one. Next it will come here. So see all the pictures which you have saved. So you can change the image size. After changing the image size, so let us change the page setup. So increase this one. Next you can save all these files. Next you can take the printout of this one later. So already it's telling export has been completed. So let us end the class. We'll solve some more problems in the next class.